Hello class. Today we're going to continue the syllabus about the centripetal force in the motion of satellites and planets. Okay. I hope you already watched this centripetal force video I showed you before. So regarding centripetal force, okay, what is so-called centripetal force? Centripetal force actually is a force where the force with the directions towards the center of the motion in circle. So, and the force is called centripetal force. Okay, let's look at this diagram. So from this diagram, actually where is the centripetal force? The centripetal force is towards the center of the circle in circular motions. Okay, when we turn these things, actually this thing going to cause force towards the center of the circle, and actually we can measure by the slaughter weight. If you carried out this experiment, actually you can determine, and you found that the faster you turn the object or the object move with a faster speed, and you will cause a higher centripetal force. And the way to calculate centripetal force is by using the formula F equals to mv squared over r. Okay, so maybe you ask, why is it v squared over r? When scientists try to relate what is the relations, actually they found that these relations. Later in the next slide I will going to prove to you lah. And why is it v squared over r? Okay, so if we compare about the centripetal force and the formula of the force, so usually F equals to ma, and the centripetal force is mv squared over r. So that means if we cancel out the m, you will get a equal to v squared over r. And if you want to find about the unit, if you have a formula v squared over r, actually v squared over r, the unit for v, v is meter per second, meter per second. So when you square it, radius is also the unit with length, meter. Okay, so you have meter square per second square over meter, and then you will get meter per second square. And this proves that if you want to calculate for accelerations, you have to use v square over r. This is only for circular motions. The way to calculate the force towards the center is by using a equals to v squared over r. Okay, so next, how to calculate the way to determine the velocity of the object that in circular motions. How we going to calculate the velocity? Okay, so let's say if there's a moon circulate Earth in circular motions. So the way to calculate the velocity of the moon to complete one whole round, okay, we can determine by the time taken. So let's say 1 month, the moon take 1 month to complete one whole circle. So if you want to determine the velocity, we can use the formula, okay, by v equals to 2 pi r over d. And how actually we can prove that this formula? So first thing is about the distance. So for the moon to complete one round, one complete turn, so we know that it has to travel the circumference of the circle. So in an object in circular motions, so the complete of one complete cycle is actually its circumference. So to calculate circumference of a circle, we're going to use 2 pi r. And to calculate the velocity, if you want to determine velocity of anything, you're going to use distance travel divided by the t, divided by the time taken, or we call period, time taken for one complete cycle. So okay, remember all this must in second, cannot use day or minute, all have to change to second. Okay, so if you combine these two, okay, if I substitute this to here, then you're going to have 2 pi r over T. Okay, this is another formula you have to know. Okay, so why we have to know this? Because later on we're going to use it to calculate another things, which is the mass of the Earth and any other object. So next, okay, the way to determine the mass of the Earth and the Sun. Okay, how actually scientists knowing that the mass of the Earth and the Sun? Okay, actually they use calculation. They cannot measure it. Of course, we cannot use any balance to measure Earth and the Sun. We can just predict what is the mass of the Earth and the Sun. So the way to determine the mass of the Sun. So first thing about the formula you already learned. First is about the Newton's universal law of gravitation, where you already learned the force is equals to Gmm over r squared. Okay, so we got two objects here. One, let's say it's the Earth, and the other one is the Moon. Let's say so. If you want to calculate the centripetal force of the objects, so this one, the m2 must be, for example, if we compare between Earth and the Moon, so the m2 refer to the Moon, okay, which moving, okay. So that's why when you cancel out the m2, you can determine the mass of the Earth. So now we got these two formula. So we try to relate it, and we try to make the relationship between these two formula. So okay, so we make it equal. First step, we make it equal. So m1 gmm over r square equals to mv square over 2. Okay, so these two are the force. So after that, we cancel out m2. Then you got we can determine the m. We bring the g over here, and the r square go up and multiply. So you got v square r square over g r. Okay, next, just I asked you to memorize one of the formula for the velocity in circular motions. So we know it's 2 pi r over t, and then we substitute this in this formula. So we're going to have, okay, I think we can solve it, this one. So you square it, when you square it, you got 4 pi square, and then r square times r square. But remember this r already cancel out, one of the r already cancel out with denominator, so you left one r. That's why in the end you're going to have r cube, and the g and the t square. Remember the t square to square, so you got this formula. Okay, so that's it. So this is the way to prove the formula on page 94. So after all, the rest of the exercise you're going to use this formula to determine the mass or to determine the periods. So okay, that's it. Thank you, class.